please turn the console to broadcast. 全体广播。Yes, today we are going to design gears. Could you please read this?
Gears are wheels with toothed edges that rotate on an axle or shaft. The teeth of one gear fit into the teeth of another gear. This lets one gear turn the other, meaning one axle or shaft can be used to turn another shaft.
Okay, gentlemen, what's the rotation direction of the big gear? Clockwise or counterclockwise? Clockwise, counterclockwise.
The big one?
The big one?
The big one is counterclockwise.
And the smaller one?
Is clockwise.
Okay, yes. They are in opposite direction.
Yeah.
Yes. Okay. Lady. So, did you see the rotational direction of the gears?
Rotation.
Direction. Rotation.
Rotation.
The green arrow. Yes. And are they in the same direction?
No.
No. Yes. Okay, next page, please. Okay, similar case is the gear transmission system. The bike. So we have a sprocket, two sprockets. They are not gears, and they rotate in the same direction. See, could you read the first point?
Here?
Yes.
The force acting on the teeth end identical for both gears. The lane moments are different. Moments equal to force to radius.
Yeah, cause like if we join hand together, yes. Like yes, like if I pull this gentleman, do I feel the same reaction force from him? We pull. Yeah, do we feel the same force? My hand and his hand. Yes, thank you. The same as the sprocket. They experience the same force. Yeah. Then, okay, could you stand up, please? Yeah. So, if her joint is the supporting point and extension your arm, yeah, just one hand. So if I push a force, this is F, and this is the arm of his length. So I apply a torque to her joint. The torque is the force times the length of her arm. Okay? Thank you. So we call this moment equal to force times the radius of the gear. So, lady, what's your name? Either way, Chinese, English. Xiufen. Xiufen, do you understand the meaning of the moment? Yeah. Force is the torque. Yeah, moment. Force times the radius. Okay. So, lady, could you read the second point?
If the driven gear is made larger, it will rotate more slowly but with a greater moment. For example, a low gear ratio on a bike or car. Okay, although it sounds not very clear, but the velocity equal to radius times rotational velocity is like the same to, Xiufen, could you stand up, please? Okay, so extension your arm. If there's a velocity at her fingertip, velocity v, then but her arm, like there's a the angle, this angle will change. So the angle
the length of her arm r times the angular velocity theta. If the angle change, angle divided by time, so the rotational velocity, and this is the linear velocity. So linear velocity equal to the length of her arm times the rotational velocity. So v equal to r times theta, d theta dt, theta divided by t. Okay, thank you. So this is the meaning by linear velocity equal to radius times rotational velocity. Okay, sweet lady, do you follow me? The linear velocity equal to radius times rotational velocity. Do you understand?
Can you say that again?
The linear velocity equal to radius times rotational velocity. Do you follow? No. Yeah, it's like, so here is a pendulum. If I rotate the pendulum, there's a linear velocity, like it will go right and left, but the angle will change.
Yes.
So the angle change times the length of the pendulum equal to the linear velocity. V equal to this r times angle change with respect to time. So velocity of this point equal to a rotational velocity times the rotational length, the radius. Yeah, just the linear velocity.
The linear is
线速度。
切线的速度。
对 ，yes.
Okay.
Yeah, okay. All right, could you read the third point?
If the driven gear is made smaller, it will rotate more quickly, but with a smaller moment. For example, a high gear ratio on a bike or car.
Okay, the point is because linear velocity is the same for the small gear and the large gear. If linear velocity is the same for both, then small radius, large rotational speed. Large radius, small rotational speed. Do you get it? If the linear velocity should be the same, right? But linear velocity equal to the radius times rotational speed. So large radius, small rotational speed. Yes? So do you know this?
Yes.
Yes, good.
Very good.
Very good. Very good. So we start this week by this simple physics. Then it's like give us a good look into the future of this week.
Right.
So everything is logical.
Yes.
It's reasonable.
Yes.
So we really like logic. If everyone could follow the logic, isn't it a very beautiful world?
Yeah, that would be ideal.
Ideal world.
Yes. Very good world.
So let's try to follow the logic. Yeah, I think okay, I like it. Logic. Okay, do you get all the points?
Oh, yeah.
Yeah. So are you happy with it?
Oh, yeah.
Next page, please. So now we have an example. Could you read this example, please?
Okay, a gear with a radius of 0.1 and is turned by a gear with a radius of 0.05 meter. The moment of the smaller gear is 20
Newton meter.
Newton meter. Calculate the moment of the larger gear.
See, we know the moment equal to the radius times the force. Then you know they experience the same force. For the small gears, you can calculate the force applied to the small gear. But you know the force applied to a large gear, the same force. So you can, after that, you can get the force of the large gear. And you also, the problem gives you the radius of the large gear, so you can calculate the moment of large gear. So do you follow this logic, this thinking logic?
Yes.
Okay, good. So now, everyone, please get a pen and a paper or whatever, your smart pad, your anything, just calculate the moment of the large gear, please. If you can just use your mind, you don't need a pen or paper or smart pad, notepad, iPad, whatever. It's okay, good. Yeah, you can just use your mind to do your brainstorming. Get the answer.
Forces is
20 Newton meter. 20 Newton meter is the moment. Newton meter. Because force is Newton, then the radius is meter. So force times the radius is, the unit is Newton meter, because Newton times meter.
Okay, so
Yeah.
this is 4.
For the small gear, you have the radius of the small gear, 0.05 meter. And the radius of the large gear is 0.1 meter. So you have the radius 0.05 for the small gear. Then you can calculate the force of the small gear.
So it's 20 divided by
Yes.
the small.
Yeah, the small one. This is the large one. 0.1 is the large one. And 0.05 is the small one.
100. Oh,
Then-
larger, the larger one.
Okay, just give you 1 more minute. Then we will turn to the next page to see the answer to this problem.
I think it's 200.
Percent force and force times radius. So you could.
This is the
Do you get the answer already? Not. Okay. Okay. Right. That's correct. Okay. Please turn to the next page. Yeah. Here is the answer. Okay. Do you get it? Do you get the answer right? 40 Newton meter. Yes. Yeah. For physics, we always like to have the number with the unit. So we like to have, you say 40 Newton meter as the answer. Otherwise, if it is Newton centimeter, then the answer could be 4,000 Newton centimeter. So that's why I'd like you to also write, remember the answer should include not only the number, but also the unit. So do you get it? Very good. Very good. Excellent. Okay, next page, please. Now we have the driver rotate in the, what's the direction of the driver gear? Clockwise or counterclockwise?
Counterclockwise.
Yes. And what's the rotation of the driven gear?
Clockwise.
Right. Good. Then the next one, the small. So we have a schematic plot for 2 gears. The bottom figure, the lower figure. So did you see the 2 gears? Then did you see the green color circle and red color circle? We call the green color circle as the pitch circle. For the 2 gears, their pitch circles should be tangent to each other. Okay? And the pitch is the distance between two gears, pitch. And the center distance, you know, is very straightforward. So do you got the nomenclature right? Do you understand all the nomenclature? All the terminology? Good, great. So let me ask one gentleman. What's your name, please?
Aaron.
Aaron. Aaron or Aaron?
Aaron.
Aaron. So what's the pitch?
Pitch. From the distance from one gear to
Yeah.
the other.
The circumferential distance between two gears. Circumferential, the arc. Okay. What's your major?
Veteran. 兽医。
Huh?
兽医怎么念？
Oh, veteran.
Vegetarian.
That sounds right. Okay. Yeah, so you are a smart guy. Why? You should be. You are going to be an animal doctor. No? Okay, fine. Next page, please. Next page. Okay, some introduction to gear. So, if the large gear has 24 gears and small gear has 8 gears, we call this is a 3-to-1 ratio. So, could you read the point? T's number
T number of driving gear
divided by
T number of driven gear
driven.
or driven gear.
We call gear ratio. So if you see this symbol, this is number. Number. Okay. Shorthand writing. Okay. So driven gear. Though 3 turns moves by 24 teeth, we have 1 turn moves by. For the small gear, it's 8 teeth, so 3 turns equal to 24 teeth. For the large gear, it has 24 teeth, so 1 turn moves by 24 teeth. So it means, do you get it?
Yes.
They should move with the same number of teeth, because their pitch are the same. For the small gear and the large gear, they have the same pitch. So that's why small gear should rotate 3 turns, and the large gear only rotate 1 turn. Isn't that beautiful?
Yes, it's very beautiful.
Very beautiful. So, what's your major?
You can call it artificial intelligence.
Artificial intelligence.
Our official name is Undergraduate Program of Creativity, Intellectual Engineering.
Also, it's in the engineering school.
Yes.
Undergraduate, first year.
Newly opened.
Yeah.
This is our first year.
Okay. So how many students are in this program?
13.
13. Oh, so it's not a large group. Okay. Yeah, so looks like you come to the right place for this major.
Yes, we did. We are very happy to be here.
Yeah. So it looks like it's more about computer science.
It's close.
Very close. Yeah. Okay, next page, please. So now train. Like, you know, if we have a large number of gears connected in series, we call this gear train. So could you read the first point?
Tangential velocity is equal to R1 by W1 or 2 by W2.
Correct. Here R means the radius and W means the rotational speed. Because everyone should I mean for the two gears contact with each other, the contact point should have the same tangential velocity, right? And tangential velocity equal to the radius times the rotational speed. So that's why we write R1 multiplied R1 times W1 equal to R2 times W2, or R1 multiplied by W1. So either way, yeah. Could you read the second point?
Radius of gear is proportional to number of teeth.
Yes. Remember, for two gears contact with each other, they should have the same pitch. So, which means large radius, we have large number of teeth. That's why they can contact with each other and rotate seamlessly. Okay. Lady, could you read the third point?
Yes. R1 over R2 equal to W2 over W1 equal to N1 over W2.
Yeah, N means the gear number. Because gear number is proportional to the radius. So if you know R1 over R2, the ratio, then you should know N1 over N2, because R is proportional to N. Do you get it?
Yes.
Good. Okay. So we have an example. So given R1, R2, and N1, what are the ratio of W2 divided by W1? And what's the value of N2? Okay, everyone, now it's your turn to work. Please get the answers of W1 divided by W2 divided by W1, and the answer of N2, the value of N2. Yeah, just
The
proportion. Yeah, you see, you got this relation. So you can use this relation for your calculation. Aaron, do you feel animal is complicated?
It's very complicated.
Yeah, and physics is simple.
Physics, you don't have to memorize a lot of things. You can memorize the
Principle.
Yeah.
Yeah, but you got to memorize a lot about animal, human, I mean animal, the biology. Complicated.
It seems you can understand, but very hard to memorize all.
Yeah.
It seems classmates just memorize, just go home and memorize that day's teaching material.
But now we have two guys doing artificial intelligence. It's like everything is very easy for you to check it up. Check it up, like you can go to the computer, the internet. You can get everything.
I think they have to put everything in the brain because there is very few time on the battlefield, and when you need it, so
Yeah.
you have to memorize.
Yeah.
And we can always go to computer, but it seems for now we have to memorize in the brain.
Yeah, for now, like it's yeah. But you'll be fine. Okay, please do the exercise. So looks like our AI guys got the answer already.
Yes.
Okay. Let me ask the others. Let's wait for a bit for everyone to finish this practice. Did you learn this in your high school? In high school, did you learn this?
This?
Yeah. Or junior high school?
I learned this, but I don't remember when.
Oh, you don't remember? But it gotta be somewhere in high school.
Yeah.
Or elementary school?
Not elementary school.
Okay. Okay, next page, please. Now, we have another, okay, previous page. 请翻到第8页. Okay, so let's get the AI guy to tell us your answer. W2 divided by W1.
2. W2. Wait, that would be, yeah, 2.
Yes, and what's the value?
And the value will be,
N2.
16, I guess.
Yes. Okay. Yes. Okay. All right. Do you have anyone has trouble to get the answer?
No, but I want to know what does W mean.
W is the radius of the gear. So,
But R.
oh, sorry. W2 is the velocity, and R is the radius.
Okay.
So, radius ratio equal to the inverse of the rotational speed ratio. R1 divided by R2 is 2.
2, so this is 2 and this is 16.
Yes. Yeah. Okay. Next page, please. Now, another quiz. So please do the quiz, everyone. W1 equal to 60 revolution divided by minute. 60 revolution means 60 turns. And minute is 1 minute is 60 seconds. So revolutions means turns. Very good. We almost got all students in the classroom. We got 22 students in the classroom, and the registration number is 24. So we only have 2 students absent from the class. Okay, so do you got the answer?
Yes.
Could you tell me the answer, your answer?
W4 I believe to be negative 60 revolution per minute, N2 to be 16, N3 to also be 16, and N4 to be 32. I believe those are the answers.
Okay. So you said W4 equal to 60 RPM.
Yes. Or negative 60 because it goes the opposite way.
Yes, yes. Yeah, right. And let me see. Okay. What's your name, please?
Sally.
Sally. So do you get the answer right?
我看一下。老师，你给我一个答案 ，W4 的答案。
Oh yeah, W4 equal to 60 RPM. 60. Okay. So raise your hand if you have problem to get the answer. Okay. Everyone got it right. Next page, please. Okay, so here we have some gears arranged in this way. We have driver, we have driven, and we have two gears between the driver and the driven gear. And the relation, we have the relation. So because R1 and R2 contact with each other, so we have R1 omega 1 equal to R2 W2. And because R2 and R3, we call them, they are attached to each other. They are in one assembly. R2 gear 2 and gear 3. See, they bound to each other. So they got to have the same rotational speed. That's why we write W2 equal to W3. And W3 and 4 they contact each other with each other. So we have R3 W3 equal to R4 W4. But gear 4 and 5, they are in the same assembly. They bound to each other. So that's why W4 equal to W5. And gear 5 and 6, they contact with each other. So we can write down R5 W5 equal to R6 W6. Right?
Yes.
Okay. So do you get it? Do you follow this? Okay. So do you have problem with this figure?
No.
Okay. Next page, please. So now we have a quiz for you to practice. Please calculate W6, the rotational speed of the gear 6, given the condition. RPM means revolutions per minute. It's a unit for rotational speed.所以你们两个练习，等一下要画那个齿轮吗？好，不要出洋相。所以你有调整那个解析度吗？等一下存档，你们要存档的解析度。
不是用分割的就好。
我用分割的就好。那你们解析度可以调吗？
我没有看。
Yes.
In the third equation, it said R4 equals to R6 and equals to R4, and we can't possibly get the answer without having this number.
R4 R4 equal to R6. R1 equal R3. R1 equal R3. R2 equal R5. So we have 1, 2, 3, 4, 5, 6. So just ignore this. Just use R2 equal R4 equal R6 equal 4 millimeter. So just use R4 equal to R6 equal 4 millimeter.
Okay. All right.
Okay. Sorry for my error. So it should be R4 equal R6 equal 4 millimeter. So do you get the answer?
Maybe.
Okay, what's your answer?
25.
25 RPM. And what's your answer?
62.5.
62.5 RPM. What's your answer?
52.5.
52.5 RPM. Okay. What's your answer?
I don't have it yet.
You don't have it yet? Okay, let me do the calculation. R1, W1 equal to R2, W2. Then W2 equal to W3. Then R3, W3 equal R4, W4. Then W4 equal to W5. Then R5, W5 equal R6, W6. So let us plug in the number R1, R3 equal to 10. R1, R3 equal 10. R2, R5 equal 5. R2, R5 equal 5. R4, R6 equal to 4. R4, R6 equal to 4. W1 equal to 10 RPM. So 10 times 10, 100, divided by 5 equal to 20. W2 is 20, W3 is all the same, 20. Then if W3 is 20, W3 is 20, then W4 should be 50. 50, 50, W5 50, 50. So 250 divided by 4 is 62.5 RPM. Okay? Okay, so now do you understand why?
Yes.
It's 62.5 RPM. Next page, please. Okay, we have some term module for gear designer. We have some like module 1, then module 2, module 3 means it's the name for gear designer because pi times module equal to P. P is the millimeter. And P equal to there's a correspondence between P and N. Then P is the pitch. So if you design a gear with pitch equal to 3.1416 millimeter, then the gear we call is module 1 gear. So that's, it's just something for the gear designer to communicate to each other. Okay, so could you read the bottom point? Pitch.
Pitch is the distance between corresponding points on adjacent teeth.
Right. Okay. Next page, please. So for module and another term for gear designer to use is diametral pitch. So the relation between module and diametral pitch, we follow the equation. Module equal to 25.4 divided by diametral pitch. Okay, just something for you to know. Okay, next page, please. Okay, we have another schematic for a gear. So we have a gear, then we have the pressure angle is the contact point. We draw a vertical line, and along the surface of the gear, we draw another line. So the angle between these two lines we call pressure angle. And we have the pitch, the corresponding point between the two adjacent gears. I mean the distance between the corresponding points on the two adjacent gears. And two surface line. And the angle between the two surface line and the vertical line, we have an angle, pressure angle. Could you read the point? The first point?
Pressure angle is the leaning angle of a gear tooth, an element determining the tooth profile. Recently, the pressure angle, alpha, is usually set to 20 degrees. However, 14.5 gears were equivalent.
Oh, okay. So someone used 20 degree as the pressure angle. The others might use 14.5 degree as the pressure angle. It's a standard for people to use. So it just, okay. All right, the boring stuff. Next page, please. Now, it's the fun part for you to draw two gears and do the simulation of the gear rotation simulation. Then I will ask the TA to do the solid work to show everyone the steps. Okay, TA, your turn. Solid works. So everyone just please watch the TA do the simulation once. After that, you can follow the steps in the PPT to run your solid work. We select a surface to draw two circles first. Okay, please go ahead. And we will make the two circles tangent to each other, but we need to assign the dimensions. Then Yeah, make them tangent to each other. After that, we will create the gears from our data bank to get the gears. Because we need a toolbox, so we need to get the toolbox first. We use the simple one, spur gears, normal gears for us. The two gears have the same diametral pitch. After that, we need to rotate the gear. Then, because we need to rotate the gear to be in the same surface as the two circles we drew previously. You need to make the rotate float, otherwise the float is fixed. We can use the function mate to mate the surface of the two circles with the surface of the gears. Then we make the circle to be concentric. That's why we drew the two circles first. Easier for us to align two gears, match to each other. Yes. You need to rotate a little bit, otherwise they will interfere with each other. So yeah, so very good. Then we do motion study. We give a rotational speed to the gear to drive another gear. Looks like we put a motor to drive the big gear. So we give the RPM value. We calculate. Okay, pretty good. So this is a motion study. And after that, we can do animation. Okay, so please follow the PPT steps and run your study work. And after you finish the simulation, you are free to go. And TA will go around to help you out. Okay, please give the control to the students. Please. If you need to go to the restroom, if you need to do anything, please go by yourself. You don't need to get my permission, okay? And for the final project, because in this class, we have no exams, we have no homework, we have nothing, but we have one final project. One final project is the final week of this semester. You will select a topic. You will